Hello friends, today I am going to discuss about mechanisms of corrosions. Before that, we have to recapitulate once that what is corrosion. Actually, corrosion is a natural deterioration process of a metal by chemical or electrochemical attack. Now, corrosion has two mechanisms. One is wet mechanism, which is actually electrochemical mechanism, and another is dry mechanism, that is chemical mechanism. Now in case of wet mechanism, here two types of mechanisms are present. One is hydrogen evaluation mechanism. It operates when a metal is placed in a acidic environment, and another is oxygen absorption mechanism. This mechanism operates when a metal is placed in an neutral or slightly alkaline environment. Now in case of hydrogen evaluation mechanism, here first the metal which will be corrugated, that will be anode, and here at anode the metal will be oxidized to Mn plus by releasing n number of electrons, and at cathode here the H plus will be reduced to hydrogen, and here the hydrogen will be evaluated. Let's see some examples. If we place a zinc rod and a platinum rod in a container which contains an aqueous zinc sulfate solution and sulfuric acid mixture as electrolyte, and then if we connect these two rods by a wire, then here first this zinc will be oxidized to zinc 2 plus, releasing 2 electrons, and these 2 electrons are conducted through this wire to this platinum, and then as here acid is present, so this H2SO4 can produce H plus, then that H plus will reduced by taking 2 electrons from this platinum electrode to evolve this hydrogen. So in summary, here the H2SO4 produce H plus, and then in anode the zinc will be oxidized to zinc 2 plus, releasing 2 electrons. These 2 electrons will reduce the acid of H plus, acidic H plus, to give this hydrogen, and this hydrogen will be evolved. And also here one thing is, here in anode this zinc 2 plus is free, and here after ionization of sulfuric acid this sulfate is in free state, hence in last step this zinc 2 plus and sulfate combine to give this zinc sulfate. So overall here this zinc and sulfuric acid reacts to give this zinc sulfate, and hydrogen will be evolved. Now if we just remove the wire between zinc and platinum, and if we touch the zinc and platinum, then what will happen? Then here also first this sulfuric acid produce some H plus, and here in anodic region some zinc will be corrugated to give this zinc 2 plus by releasing 2 electron by oxidation method, and then these 2 electron reduce this acidic H plus to evolve hydrogen. So here also the sulfuric acid first ionized to H plus and sulfate, and then in next step the zinc will be oxidized and releases 2 electrons, and then in cathode the H plus will be reduced to give the hydrogen, and here also the free zinc 2 plus and this sulfate combine to give zinc sulfate. So here also the overall reaction is same as previous, that is the zinc and sulfuric acid reacts to give the zinc sulfate in aqueous phase, and hydrogen will be evolved. Now here it is another example of iron corrosion. Here actually if we take a iron sheet in an environment where moisture and carbon dioxide is present, then this iron sheet will be corrugated. Here first actually this water and carbon dioxide produce carbonic acid, and then here this iron sheet can be hypothetically divided into two parts. One is anodic part and another is cathodic part. Now here from this anodic part the iron will be oxidized and is corrugated to Fe2 plus and producing 2 electrons. Now these 2 electrons directly passes from this anodic part to cathodic part through this metal sheet, and then at cathode here the H plus from carbonic acid will be reduced to give the hydrogen. Hence here first the carbonic acid will be ionized to H plus and carbonate, and at anode the iron will be oxidized to ferrous, and also at cathode the H plus will be reduced to give hydrogen. And here also this free carbonate and this free ferrous combine to give ferrous carbonate. Now this ferrous carbonate is in precipitated form. So here overall the iron will react with this carbonic acid to give the ferrous carbonate precipitate, and hydrogen will be evolved. Now also the rusting of iron can be happened by oxygen absorption mechanism. Actually in case of oxygen absorption mechanism, if we place a metal in an environment where the aerial oxygen and moisture present, then it will be corrugated. Also here some OH minus or hydroxide can be present, but the presence of hydroxide is not necessary, but can be present. Now here actually what happened, here first at anode the metal will be oxidized to give the Mn plus and releases n electrons. Here actually n is a variable, and the water and oxygen from environmental moisture and aerial oxygen respectively will be reduced to give this hydroxide ion at cathode. Now question is here, what is anode and what is cathode? Actually if we take a free metal ion or a free metal rod, that is iron rod, raw iron rod, then as this environment is basic or neutral, hence this iron rod is naturally coated by a oxide layer, that is some iron oxides coated this layer, this iron. Then by cracking of this oxide layer here, if we crack some portions of this oxide layer, then the pure iron will be exposed in this portion, and this exposed portion is anode, and this oxide coated portions acts as cathode. Now here at anode first iron will be oxidized to ferrous ion by releasing 2 electrons, and these electrons passes from this anodic region to this cathodic region, and then the environmental oxygen and moisture will be reduced to give the hydroxide. And as this ferrous ion and these hydroxides are free, hence in the last step these ferrous and these hydroxides are combined together to give this ferrous hydroxide, as here this ferrous ion and hydroxide combined to give this ferrous hydroxide, and further oxidation of this ferrous hydroxide gives the ferrous oxide, actually ferric oxide, and here some crystal water also present, and this is called actually rust. So here in overall the iron will react with the environmental oxygen and moisture to produce the ferrous hydroxide, which will be further oxidized to rust. So thanking you for watching this. Now in next classes we will discuss about the prevention method of corrosions. Okay, thank you. Good night everyone.